Assume that the random variable z is normally distributed with a mean of 0 and a standard deviation of 1. If p of negative b less than z less than b is equal to 0.8322, find b. Please round your answer to 2 decimal places. All right, now let's break this down a little bit. Remember that the notation here, p, stands for probability. And when it comes to normally distributed distributions or with normally distributed random variables, area and probability are the same thing. So when they tell us p of z between negative b and b, what they're saying is that there's an area under the bell curve between two values that have the same distance from 0. And they've given us what that total area is. So let's go ahead and sketch that out on our curve. So since these are z-scores, we know the mean is 0 and the standard deviation is 1. We don't know exactly where these b values should go or where the borders are or the boundaries for our shaded region, but we do know that they're the same distance from 0 since it's negative b and positive b. They're the same value, just different signs. So let's just put our negative b here and our positive b the same distance on the other side of 0, where the mean is. Now, we may have placed them too close to the mean or too far from the mean, but we'll know that after we do the reverse lookup or inverse lookup using the normal distribution. So the area in between them is 0.8322. Now, if we want to use the norm.inverse function in Excel, or if we want to look it up in the z-table, what is usually the most common thing to use is a left area. So with Excel, the left area is definitely needed in order to use norm.inverse. And if we can figure out what this is, we can use norm.inverse in Excel to find the negative b, and then we'll all automatically know what the positive b is because it'll be the same just without the negative. So how do we find this left tail area here? Well, we use our knowledge of the entire area under the curve being 1, combined with our knowledge that the normal distribution is perfectly symmetric across the mean, meaning that if you divide the bell curve in half right through where the mean is, there is exactly the same area on both sides. It's symmetric everywhere. Like if you fold it on this line, everything matches up. And we know that the total area is 1. So all we need to do is start by subtracting the middle area, 0.8322, from 1, and that'll give us what's left in the two tails together. And then we'll know that whatever that area is that makes up the two tails total, half of that would be in the left tail. So what we're looking to do is calculate, I'm going to do it down here, 1 minus 0.8322, okay? So that gives us the total area in both tails. And then the left tail area is going to be half of that. So let me just do a little notation here. Total tails together, okay, is 0.1678. And the left tail only would be half of that since the two tails are exactly equal. So we're just going to take the total tail area and divide it by 2. And now we have our left tail area, which allows us to now find the area, the boundary right here that is bordering that left area by using the reverse lookup option. So we're going to do norm.inverse and then put in the probability, which is in the left tail, because it only works with left areas, and then the mean given in the problem. And for this one, since it is standard normal with z-scores, the mean is 0 and standard deviation is 1. And then true for cumulative Oh, actually, you don't have to say cumulative for the inverse function, only for the regular distribution function. So this is all we need. And here is our negative b value, which means that our positive b value rounded to 2 decimal places is 1.38.